So I typically give out a homework that looks like this, right? For the list homeworks, I typically give this around week 2, where basically I ask you to write a method that does each of these things, right? So the first one is uniqueness. We'll write a method called unique, which takes in a list and returns true if all the items in the list are unique. So all the items in the list are unique if none of them are the same. Okay. Now typically the way you code that somebody would code that up is by, well, let's go ahead and try over here. Public static e, taking e's, e boolean unique list of e list. Right. So this would be a list that takes. This would be a list of items of some kind, and we'd be checking to see if all the items are unique, right? And we'll assume that all the items in the list are unique until proven otherwise. And typically, you come up with something like this: for int I is equal to 0, I is less than. So typical iteration, list.size, I++, right? Iterate through all the items. E item is equal to list.get I. Then what we'll do is that we compare it to every item that it hasn't been checked against yet. So every item to the right of it. For int j, common mistake there, is equal to I plus 1. I is j is less than or equal to list.size j plus plus, right? So for every item to the right, not less than or equal to j plus plus, if item dot equals j, list dot get j, return false, right? So if those two, if the item is equal to the item or one of the items to the right of it, then we found a duplicate, so we return false, right? Now this algorithm, because it iterates over, basically, for each of the items, you iterate over n items. All right, well, technically, it's, for each item, for the first item, you do n-1, then n-2, then n-3, then n-4, and so on and so forth. So it becomes 1 plus 2 plus 3 plus 4, all the way up to n-2 plus n-1, which we've seen is big O of n squared, right? So this, or if you just simply count the nested for loops, right, you'll go, oh, that's an O of n squared algorithm, right? This is the typical way you do it. But if you're willing to use a hash set, then we can get this down to a linear time algorithm, an O of n algorithm. There is a trade-off there, and it is the eternal trade-off that we make whenever we're dealing with hash tables, which is that we are basically going to be sacrificing a noticeable amount of space, enough space that we should just make sure that we understand that we are sacrificing space to get a speed up for time. And we'll see why that is later. But we are essentially sacrificing space to the time gods to lay their blessings upon us so that we can get better time. So the way we would do this instead, if we want constant time algorithms, is we would first create a hash set. So set E is equal to, set is equal to, I'm going to go ahead and call it our checklist, right? Everybody's seen our check. It's equal to a new hash set. And this is just simply going to be the things we've seen yet. If it's in our checklist, then we've seen it. If it's not in our checklist, we haven't seen it. Okay? So for each item, each E item in the list, right? For every single item in the list, what are we going to do? If checklist dot contain, so for each item we're going to look at it. does the checklist have that item in it? Well, if it does, return true. We're done. Oh, sorry, return false. Ugh, return false. We've seen it. We're done. There's nothing unique in there, right? Or rather, we've proved that this is not unique because we've seen it before. It's in our checklist, and we check to see, does it have this item? So we're done. Otherwise, if it's not in our checklist, what we do is that we go ahead and just add it to our checklist. Oh, we haven't seen it yet, so let's go ahead and add it and make note that we've seen it. Checklist.add item. And that's it. That's all we need. So the big reason why this takes O of n time is that we have this single for loop here, and this contains method takes constant time, and the add method takes constant time. Unlike the list contains, and which would take O of n time, this takes O of 1 time.